Good morning. Today we are going to start the Unit 4. Unit 1, Unit 2, Unit 3 is completed. I have already told you that Unit 3 consists of two parts, design of shallow foundation and pile foundation, which is also called as deep foundation. So pile foundation, three parts we have covered: necessities and usage of piles, pile installation or driving, and third components we have also completed: single and double underring piles. In addition to that, many things which we have covered in fifth semesters: pile settlement, group settlement of piles, group efficiency of piles, negative screen frictions. So all components, all the parameters which we have discussed in pile foundations in fifth semesters, including numericals also, you have to revise. Wherever you have any doubt, you can talk to me or you can give your comments through the Google Classrooms. So we shall go for the Unit 4 today. You can see Unit 4 also consists of two parts: introductions. The first part is related to the well foundation, right? This is the parts of the deep foundation. Deep foundations, pile foundation, pier foundation, and well foundation, which is also called as castle foundation. So pile and pier we have already discussed. So we shall go for the well foundation. The first part of the Unit 4 is the well foundation, and second part is the retaining walls. So today we shall start the well foundation. We can see that the well foundation have been used in India for centuries for providing deep foundation below water for monuments and bridges. First well foundation was constructed in our country for the Taj Mahal at Agra. This is constructed on the well foundation, right? Already I have explained you that the well foundation or castle foundation, right? So we shall see the components of a well foundation. Definitely, we have to construct the well foundations below the river bed. It is used in water for bridges, right? You can see this is the river bed. You have to understand this figure, which are very important, and the components are normally asked in your examination and will be asked, what do you mean by the steining? You can see a steining is nothing but it is the walls of the well foundation. Wall of the well foundation is called a steining. You can see the curb. Curb is provided between a steining and cutting edge. Cutting edge also given here, so that cutting edge facilitate the movement of well foundation inside the earth, right, below the river bed. You can see here di is the internal diameter of the well, de is the external diameter of the well, capital D is the depth of penetration from the river bed, and ts is the thickness of steining. You can see here concrete seal or bottom plug is also provided. Once the well is completed, right, once the installation or construction of well is completed, we have to fill the bottom part of the well by the concrete, right, so that the superstructure load will be distributed uniformly at the bottom of the well. The second things, why we go for the concrete ceiling or bottom plug, it also controls the uplift pressures, right, uplift pressure on the well. So steining, curb, cutting edge, concrete seal or bottom plug. You can see top plug is also there on the top. Once you are going to fill the well by the sand filling, then we shall close this sand filling by providing top plug. Above that, RCC slab is there, that is called a well cap, and above the well cap we have to construct the pier, right? In Hindi it is called as pier. So pier we can construct, and above the pier we can go for the construction of construction of railway bridges or the road bridges, or we can go for the laying of railway girders, right? So above the piers. So we shall go one by one the definition of these components. We can see here cutting edge. What do you mean by cutting edge? The bottom, you can see at the bottom cutting edge is given. Cutting edge, the function of the cutting edge is to facilitate penetration or sinking into the soil to the desired depth, right? It should be sharp and strong to resist high stresses subjected during sinking process. It should be sharp, otherwise it will not go inside the earth. It is made up of angle iron with or without an additional plate of structural steel. Normally it is made up of angle iron. The next definition is steining. As I told you, steining is nothing but it is the walls of the well. It's called as steining. The steining is constructed with brick or stone machineries or with plain or reinforced concrete occasionally. The thickness of the steining is made uniform throughout its depth. Why? Why it is required to make the thickness of the steining uniform? So that uniform installation will take place. Uniform sinking will take place, right? It transfers the load to the soil, subsoil. It also acts as a coffer dam during sinking and provides the weight for sinking. Weight for sinking. We have to maintain the thickness of the well, thickness of the steining, not thickness of the well, thickness of the steining in such a way so that by its own weight it will start moving inside the earth, right? Definitely the laborers are going inside the well and they are excavating the soil from the edge of the well so that the well will go inside the earth easily. It also works as a coffer dam. Means what? Coffer dam means it is going to restrict the flow of water. The water will not going inside the well because it is going to stop the water so that we can remove the water through the pumping and we can make the river bed dry for the construction purpose or for dredging or for removing the soil from the edge of the well, right? Next is the curve. Curve is nothing but curve is in normally it is a transition member. Transition member means the connecting part in between the steining and cutting edge. It is tapering in shape. Normally it is tapered in shape. It is usually made of reinforced concrete and is subjected to severe stresses during the sinking process. So RCC made up of RCC. The curve is made up of RCC. I will upload one videos also, one or two video lectures, how the well sinking is taking place in the river, so that you will have more concept. The next definition is, or next components also we can say of the well foundation, concrete seal or bottom plug. After the well foundation is sunk to the desired depth, we have to sink the well up to our required depth, right? So as to rest on a firm stratum. Firm stratum means hard strata. It will sustain, it will retain, right, on the hard strata. A thick layer of concrete is provided at the bottom inside the well, generally underwater. This layer is called a concrete seal or bottom plug, which serve as the base for the well foundation. It serves as a base for the well foundation, and then we shall fill the sand above it. What it does? The concrete plug distributes the loads on a large area of the foundation, hence may be omitted when the well is made to rest on a hard rock. See, omitted, what is written here, it is highlighted, it is underlined also. Omitted means what? If you are going to sink the well in the river up to the hard strata, if hard strata is there, concrete sealing is not required, right? If hard strata is not there, in that case you have to go for the concrete seal or bottom plug. Next components of the well is top plug. You can also remember the figures. The figure is also required to draw in the examination if it is asked. You have to also remember all the components, all the definition of the components. Top plug, after the well foundation is sunk to the desired depth. Once you have sunk the well up to the desired depth, the inside of the well is filled with sand, right? Either partly or fully, and a top layer of concrete is placed. This is known as top plug. Once you are going to fill the well by the sand, then you can close it by using the top plug. The top plug, the concrete serves to transmit the loads to the base in a uniform manner. And definitely sand should be compacted inside the well in a proper way. The top plug provides contact between the well cap and the sand filling. As you know, above the top plug, we can construct the well cap. So, in between the well cap and the sand filling, it helps in transferring the load through the sand filling. Next is the well cap. The well cap serves as a bearing pad to the superstructure. Once you have constructed the top plug, then we have to go for the well cap. On the well cap, you have to start the construction of the pier, right? Pier, and on the pier, then you have to go for the girder, or you can construct the railway. You can lay down the railway lines, or you can also go for the road construction. What it does, you can see here, the well cap serves as a bearing pad to the superstructure, which may be a pier or an abutment. It distributes the superstructure load onto the well, staining uniformly. Because the walls of the well, which is called as staining, is going to take the load of the superstructure, load of the structure. So what is pier or abutment? Do you know what I mean by pier and abutment? This figure. For your understanding, I have given this figure, the pier, right? Pier and abutment both are the same, but when it is in the the pier, when this is in river water, that is called a pier. But when it is constructed at the edge of the river, right? At the edge of the river, which is called as abutment. So you can see the well foundation, above the well foundation, abutment is there, pier is there. Now we shall go for the next topic, shape and size of well foundation. Wells are constructed straight and vertical sides from bottom to top. If you are not going to construct the well straight, what will happen? The proper sinking will not take place by its own weight. So, what are the various types of shape and size? The shape of the well in plan may be circular, right? A square, rectangular, octagonal, twin circulars, twin rectangulars, twin hexagonals, twin octagonal, or double T, right? These are the shapes of the well foundation. We shall discuss one by one. The choice of shape of a well is governed by the outline of the base of the superstructure. Superstructure means pier or abutments. What is the size of the abutment? What is the size of the pier? Which size you need? Accordingly, you have to use the shape, right? Shape of the well foundation. Shape of the well foundation means what? Suppose you are going to use a single circular well as a well foundation. In that case, the space will be limited. If you are going to use the twin circular wells, So one wells you can use for going purpose, and another wells you can use for the coming purpose. Like that also you can use for the railways or for the roads. The circular or pointed shape is preferred on the upstream side to minimize the possible impact from large and heavy floating objects. What does it mean? See, in the river, upstream, downstream is there. Upstream means from which the water is coming. So pointed part we have to put along the upstream side, right? Suppose you are not going to put the pointed shape. Let us take the example of double D well or any rectangular wells. If the rectangular length, suppose length is on the upstream side, what will happen? It will the well will feel more stresses due to the pressure of water coming on the or coming and striking on the length of the wells, right? So that things we have to take care of, that the pointed shape or the width we can say, or the small dimension part we have to put along the upstream side, so that it will the well will not feel more stresses. That is our target. Now we shall go one by one. Circular well, you can see circular well, the figure of the circular well. Circular wells are simple in construction. It is very simple, easy to sink, and require minimum staining thickness due to low flexural stresses than in other types. Low flexural, low bending stresses in the walls of the well. Walls means staining. Circular wells possesses high strength and are subject to low bending stresses due to the absence of sharp corners. Because no sharp corners are there, see, surrounding the wells, right? So the dimension along the upstream side or right or the downstream side will be same. So there is no problems. So low bending stresses, because if you have more stresses is there on the wells, the more bending stress will occur. So that they require only one dredger for sinking. See, you can see this figure, dredger. Dredger is to remove the materials or soil, right? Or we can say excavate the soil from the well. You can put inside the wells and then you can remove the materials. They require only one dredger for sinking due to constant distance from the center of the dredge hole. Chances of tilting of wells during sinking are less. Whenever, see, the well is going to sink by its own weight. So, in this case, there is a chance of tilting is very, very less. Tilt means inclined. It will go vertical inside the earth. There is a less chance of tilting in this case. Circular wells are used for piers of single line railway, right? Because more space is not there. So single line railway you can use, or and the double lane road bridges. So this is dredger machines, how the dredger is going to be used for excavating the material. The next well is the twin circular wells. See, two circular wells means there are two independent wells. You can see two independent wells placed very close to each other and having a common well cap. You see, whenever you are going to sink the two circular wells simultaneously, definitely it is sunk simultaneously. So both are connected by the same well cap on the top, right? Twin circular wells are advantageous when the depth of the foundation is small, right? And the foundation soil has high bearing capacity. In that case, because the well is going to retain on the hard strata. If hard strata is nearby from the river bed, right? In that case, these wells will be more beneficial. However, the main disadvantage is that a very important point, is that disadvantage that there will be a differential settlement and tilting between the two wells with the loosening of sand between them or due to unequal sinking, even though the two wells are easily connected by a heavy top cap, unless the soil or rock is uniform. What does it mean? See, suppose you are going to sink the two wells simultaneously, and below the first well, if the soil property is different, and below the second well, soil property is different, right? So there is a chance of differential settlement. If there is a hard strata below the bottom of the both the wells, it will be better, right? Or suppose you are going to sink the wells simultaneously, and in between the two wells, if the sand is there, right, and there, if there is, suppose sand is going to lose, in that case it will also move here and there, right? So that is a major. The next well is called as a square or rectangular wells, right? Either we can go for single square or rectangular, single rectangular, depending upon the space. If you need more space, right, either for the railway bridges or the road construction, we can go for the twin rectangulars or the double rectangulars or double squares, right? So what it says that a square or rectangular section is used for well foundation of a small depth up to 8 meters. 8 meters means what? From the river bed. For large size piers or abutments, pier or abutment already have told you in the previous slides. Again, I have given these slides. Abutment, the end part of the bridge, the pier which is available, and the end part of the bridge is called an abutment. So for large size piers or abutments, double rectangular wells with two dredge holes are used. Two dredge holes means you can see two rectangular wells or two square wells means what? Two dredge holes are there. You are going to use the dredger for excavating the materials from the both the wells, right? And we can say two holes are there. The bending stresses are, however, very high in the steening due to sharp corners. The bending stress, you see, these wells, squares or the rectangulars, have the sharp corners, 90-degree corners. So these corners will create the stress or pressure difference from outside and inside. Inside you have filled the soil, sand. So inside pressures and outside pressure will be, if different pressures are there, in that case there is a chance of tilting. Now we shall go for the double D wells. Double D wells, you can see it is just like a double D. D alphabetical letter is there, double D. So what you say that an improvement over twin rectangular or twin circular wells have and have two dredge holes each in the shape of a letter D, right? Alphabetical letter D in the shape of the two dredge holes are there also here. Double D wells. What is their advantage? It has high lateral stability. Lateral stability means what? This foundation can take more stresses when the water pressure in the river from the upstream side is very high. It will be more stable, right? There is no chance of movement or tilting or collapse. So that advantage is there. When the size of the pier or abutment is large and cannot be accommodated on a single circular well, what we can do? Double D wells will become the most economical. Easier to sink than double rectangular or octagonal wells, but require larger sinking effort. Effort is required more here. What is the disadvantage? The bending moments are larger on the steening. Steening means walls of the wells due to the differences in pressure between the outside and inside. Here also the inside, because in the dredge hole you are going to fill the sand, outside water is there. So due to the pressure difference, there is a difference in bending moments also. This problem also may occur in this case. The well is prone to more tilting. It may not go straight. Why? Because due to the pressure difference inside the well and outside the well, there is a chance of tilting. At the corners of the dredge holes, easy access will not be there for dredging equipment. Dredging machine, I have shown you the figure. The dredging machine have to go inside the dredge hole to excavate the soil from the river bed, right? Once the excavation will not, unless excavation will not take place, the wells will not go inside the earth, below the river bed. So here it is very difficult in this case. Easy access of the dredging machines to remove the soil from the corners is difficult. So next and last shape of the wells is double octagonal or hexagonal wells. So hexagonals and octagonal wells have the advantage that the sharp corners present at the junction wall between the two dredge holes of a double D well are eliminated. A very important line. What does it mean? You can remember the rectangular wells. You can remember the double D wells. In case of double D wells, one D is left hand side, another D is right hand side. In between, wall is also there, right? And that wall is having the sharp edges, sharp corners. So that problem is going to be eliminated in this case of double octagonal and hexagonal. Here sharp corners are not there inside the wells compared to rectangulars or double D wells. So that benefit is there. However, surface area is more than that in double D sections, which increase the resistance to sinking. So this creates problems in sinking. Concrete is also more difficult in sinking. This is also a disadvantage. You are going to construct the hexagonal shape or octagonal shape. So this will create problems in concreting also. Double hexagonal octagonal section accommodate the full width of the bridge more economically than a single section. Why and how? Because you are going to have more space, right? Compared to the other well foundation. Other means double rectangulars, double D wells, right? Here we can have more space for the construction of piers or the accommodation of the more width of the roads or the railway, right? So that benefit is there in this case. So thank you very much for this, for listening patiently this lecture.